For decades, it looked quiet. In a galaxy about 300 million light-years away, in the direction of Virgo, there was nothing obvious screaming for attention. No blinding jet, no famous cosmic explosion, no dramatic signal that made it look like one of the strangest objects in the universe. Then, near the end of 2019, the center of that galaxy began to brighten. At first, it was mysterious. Astronomers saw the galaxy changing in optical light, but the cause was not immediately clear. The galaxy, known as SDSS 1335 plus 0728, had appeared inactive for years, but something at its heart was turning on. And now scientists believe they may be watching something extraordinary, a giant black hole waking up in real time. This black hole has been nicknamed Ansky, and it is not just becoming brighter, it is erupting. Again and again. These eruptions are called quasiperiodic eruptions, or QPEs. They are short bursts of X-ray light that repeat at roughly regular intervals. In Ansky's case, the eruptions are so powerful, so long-lasting, and so unusual that astronomers are struggling to explain them. ESA says this is the first time this kind of QPE behavior has been seen in a black hole that appears to be waking up. This is what makes the discovery so dramatic. A black hole is supposed to be invisible. It does not shine on its own. Light cannot escape from inside its event horizon. But when material falls toward a black hole, the region around it can become one of the brightest and most violent places in the universe. Gas and dust do not simply fall straight in. They swirl around the black hole, forming a superheated disk called an accretion disk. Inside that disk, matter is crushed, stretched, accelerated, and heated to extreme temperatures. Before some of it vanishes forever, it releases enormous energy. That energy can shine across hundreds of millions of light-years.
For a long time, Ansky appeared quiet. Then it began to brighten. Astronomers now classify its central region as an active galactic nucleus, a galaxy core powered by matter falling toward a supermassive black hole.
But the real shock came later.
In February 2024, astronomers detected repeating X-ray bursts from Ansky using space telescopes including ESA's XMM Newton and NASA's NICER, Chandra, and Swift. These were not random flickers. They were quasi-periodic eruptions, repeating on a strange rhythm.
A cosmic heartbeat. A signal from deep space. A black hole that had been quiet was now flashing in X-rays. And Ansky's eruptions are extreme. ESA reported that these bursts are about 10 times longer and 10 times more luminous than typical QPEs. Each eruption releases about 100 times more energy than eruptions seen in other QPE sources. The pattern also repeats on the longest cadence observed for this type of event, roughly every 4.5 days.
Imagine that. Every few days, somewhere in a distant galaxy, the environment around a giant black hole explodes in high-energy light. Then it fades. Then it erupts again.
The big question is, why?
One possible explanation involves a star being destroyed. When a star passes too close to a black hole, gravity pulls harder on the near side than the far side. The star can be stretched into a long stream of material, torn apart in what astronomers call a tidal disruption event.
Some of that shredded star forms a disk, some of it falls in, some of it blasts out radiation bright enough for telescopes to detect. But Ansky may not be that simple. According to ESA, there is no clear evidence that Ansky recently destroyed a star. That makes the mystery deeper. Instead, the disk around the black hole may have formed from gas captured from its surroundings. If that is true, then the eruptions may be caused by something else repeatedly disturbing the disk. One idea is that a smaller object is orbiting near the giant black hole. It could be a star, a dense stellar remnant, or perhaps even a smaller black hole. Each time it passes through the accretion disk, it creates a shock. The gas heats violently, X-rays flare. Then the object continues its orbit and comes back again. That could explain the repeating bursts, but Ansky is not behaving like other known QPE sources.
Its eruptions are longer, its energy is greater, its rhythm is slower. It does not fit neatly into the models scientists already have.
And that is why astronomers are so interested. When the universe gives scientists something that does not fit, it is not a failure, it is a doorway. Ansky may reveal how dormant black holes become active. It may show how accretion disks form around supermassive black holes. It may help explain why some galaxy centers suddenly switch on after years of silence. It may also help scientists understand what happens in the most extreme gravitational environments in the universe.
Near a black hole, space and time are distorted. Matter moves at incredible speeds. Magnetic fields twist and snap. Gas heats to millions of degrees. Radiation erupts from regions smaller than our solar system, but powerful enough to be detected across intergalactic space.
And yet, the black hole itself remains dark. The light is not coming from inside the event horizon. Nothing escapes from there. The light comes from the final chaos outside the boundary, from matter still visible before it disappears. That is the strange beauty of black holes. They are dark objects that can create brilliant surroundings. They are invisible monsters that reveal themselves through the destruction and heating of everything around them. And in Ansky's case, we may be seeing the beginning of that process.
This is rare because astronomers usually study black hole activity after it has already been happening for a long time. They see a galaxy that is already active. They see jets already launched. They see disks already glowing. But here, the change appears to be unfolding while we watch.
A once quiet galaxy begins to brighten. Years later, powerful X-ray eruptions begin. Then telescopes across space continue monitoring it, trying to understand what has awakened. ESA's Newton is especially important because it can observe the X-ray behavior between eruptions, not just during the brightest flashes. That helps scientists measure how much the system changes between quiet phases and active bursts. That detail matters. The silence between the eruptions may be just as important as the eruptions themselves. How dim does Ansky get between bursts? Does each eruption release the same amount of energy? Is the rhythm stable, or is it changing? Is something slowly spiraling inward? Is the disk growing, breaking, or reorganizing? Every flare is another clue, and every clue points toward a system that is still evolving. This discovery also matters because it may connect to the future of gravitational wave astronomy. ESA has noted that repetitive events like this may be important for future missions, such as LISA, a space-based gravitational wave observatory designed to detect ripples in spacetime from massive cosmic systems.
That means one day, scientists might not only see events like this in X-rays, they might also detect the space-time waves created by objects moving around giant black holes. That would open an entirely new way to study these systems.
Instead of only watching the light, we could also sense the motion behind the light, the flash and the ripple, the eruption and the orbit, the visible violence and the hidden gravity. For now, Ansky remains a puzzle. Why did it start brightening in 2019? Why did strong X-ray eruptions appear later? What object, if any, is punching through the disk? Why are the bursts so powerful compared with other QPEs? And is this truly what a black hole awakening looks like? The most exciting answer is also the most honest one. Scientists do not fully know yet, but that is what makes this discovery so valuable. Ansky is not just confirming what astronomers expected, it is challenging them. It is forcing new models, new observations, and new questions. This is how science advances, not through perfect certainty, but through mysteries that refuse to disappear. A quiet galaxy becomes active. A dormant black hole begins to feed. X-ray bursts flash on a repeating rhythm. The models struggle. The telescopes keep watching. And somewhere, 300 million light-years away, a cosmic monster continues to pulse. When people imagine the universe, they often picture silence. Stars frozen in place, galaxies drifting slowly, black space stretching forever. But the real universe is not silent. It erupts, it collides, it tears stars apart, it wakes sleeping giants. Ansky reminds us that the sky is alive with events our eyes cannot see. The visible stars are only the surface. Beneath that calm appearance is a universe of X-rays, gravity, shock waves, and extreme physics. A black hole that once seemed quiet is now announcing itself across space. Not with sound, not with fire, but with repeated flashes of high-energy light. A heartbeat from the darkness. A signal from a galaxy far beyond our own. A rare chance to watch a supermassive black hole change before our eyes. And this may only be the beginning. The next observations could reveal whether the eruptions continue, fade, accelerate, or transform into something even stranger. Ansky could become a key object for understanding how black holes feed and how galaxies evolve.
Or it could surprise scientists again, because black holes have a way of doing that.
They hide in darkness. They bend space and time. They consume matter. And sometimes, after decades of silence, they wake up.
Ansky is one of those moments. A distant black hole, once quiet, now erupting in real time. A cosmic engine turning on. A mystery still unfolding. And a reminder that the universe is not finished telling us what it can do. The giant has awakened, and astronomers are watching.